Hello everyone, welcome back to Statistic 1, Chapter 2, Representing Data and Interpreting Data. Topic Histogram. So histograms are used to illustrate continuous data. So for the set data below, we have the data move from 7.5 to 11.5 and then they keep moving from 11.5 to up to 28.5. So they are called continuous data. So data which has no gap in between, we call that continuous data. So in a histogram, the column in a histogram have different width and the area of a column is proportional to the frequency. So the greater the area of a column, the greater the frequency of the data range. Unlike bar chart, there are no gap between columns because one class ends, next class begin. So for example, for this one, this when the group class end, the next class begin right after it. So there will be no gap in between. So this one is the oval shape of a histogram. There are two axes. So the first one, we have box, columns. They're all next together and there are no gap in between. Straight line here. So this one we call the frequency density. The x-axis, the vertical axis, represent the frequency density, and this one represent what the data represent. Like for this one, the h. So right here, h in centimeter. So how we can find frequency density of this one from the table? So frequency density is equal to frequency over class width. So for this one, how we can calculate class width is that class width equals to the upper boundary minus the lower boundary. So for this one, the upper boundary is 11.5 and the lower boundary is 7.5. So class width is 4 here. 15.5 minus 13.5 will be 2, and 28.5 minus 25.5 will be 3. So we take our frequency divided by this one. So here, 1 divided by 4 will be 0.25, and 19 divided by 2 would be 9.5. So for our frequency, for our histogram, here's a tip for you guys. So in the provided paper area, you have to draw it as big as possible, because for examiner, when they provide you this piece of paper and you draw something like this, and your maximum is in here, it's not really appropriate. So we should use as much as possible the area that we are provided for the histogram. So here we denote that frequency density. So the maximum value is 9.5. So you have to make a scale. So the nearest to 9.5 is 10. Usually we make the largest one is 10 up here, and we see where our scale is appropriate, 10 and 5, and here we have 6, 7, 8. So they are in between here will be 0.5. Easy to read. You have to make your scale clear. And here, because our data ranging from 7.5, it doesn't start from 0, but the axis actually start from 0. So in order to not to wait the area that we want to use, we use the symbol here, the symbol, and then we start with our 7.5 here. So this symbol will mean that from 0 to 7.5, there are no values in here. So after that, we will have a histogram, no gap in between. The area represents there and here. I have an example for this one. 0.25 be something low, this low, and from here to here is 4. So here, from here to here is 4. So a very small one, 11.5. And the next one, 2, and high is 1.5, which is 6 times greater, taller than this one, 6 times here. But because the class width is only 2, so the width of this column is smaller. But this one is bigger, but the H is higher. So it also represents the frequency of this one. It does not depend on the width. It depends on the areas of the column, depending on the area, which is the class width, this one, multiplied by the frequency density. So it depends on the area, not the class width. So you don't have to be scared that this one has higher frequency. So why it is smaller than this one in class width? It depends on area, not on the class width. As what we talked before, so histograms are used to illustrate continuous data. So here I have an example. A crate containing 270 oranges was opened and each orange was weighted to the nearest gram. The masses was found to be distributed as in the table. So here we see from 60 to 99, and here's from 100. Are they continuous? Yes, they are, because in here they say that the mass of each orange was weighted to the nearest gram. So any of the orange which has is marked greater than 59.5, greater than 59 greater or equal to 59.5 will result in it that will be rounded up into 60. So any of the oranges which is smaller than 99.5, so they are rounded to 99. So from the next class, any of the one which is greater or equal to 99.5 will be rounded up to 100. So when we convert that one into this one, into the new masses, they run from 59.5 to 99.5, and here is 159.5 and to 219.5. So they're continuous data. So now we can use a histogram to present the data. So for this one, first we have to find the frequency density of each class in here. So frequency density. So for this one, they range from 59.5 to 99.5. So let's take the upper boundary, 99.5 minus a lower boundary, 59.5. We have our class width is 40. Our class width here is 40 here. So our frequency is 20. So frequency density is equal to frequency divided by class width, G 0.5. In here, the class width is 20. So frequency density is equal to 3. 60 divided by 20 is 3. The same, we have 4 for this one. We have 2.5 for this one. And here we have 1 for this one. So now we will construct a frequency, a histogram to represent the data. The vertical axis, which is frequency density here. Because our data ranging from 60 to 219. So the first one, we have to draw the symbol here, then we draw the last red of the line here. So for frequency density, our maximum is 4, so I choose 4 here. Here will be 2, 3, and 1 in here. So the first class is 60, but remember that when you take the S1 exam, you are more likely to lose a mark in here because you didn't know this one, because it ranged from 59.5. it did not start with 60. So when you draw, first of all, you don't write 60, you write 59.5. you have to write 59.5. you are not allowed to write 60. If you write 60 in here, you will lose a mark, probably, for sure. So please remember that. So the first one, the first one will be 0.5, which is this one here, 0.5 here. This one is 99.5. So the next one, the frequency density is 3 and the mass is 20, ranging from 20 here. After this point, it's only 109.5. So after 3 here, 3 here. So the next one will be 139.5 up to 4, this one 4, and the next one 159.5. so this one is 2.5, which is in here, 2.5, and the last one up to 219.5. Scale weaker, 219.5. so the frequency density is 1. So here's how we can construct a frequency density, a histogram based on frequency here. Please remember that these groups are continuous and you have to take account for, because they are round up to the nearest gram, so you have to think of these things. So when for a data set that you see in here, you have to remember that the classical width in here is not 99 minus 60, it is 99.5 minus 59.5, which is 40, not 39. Remember that. And when you draw a graph, please remember that you are not allowed to write 60 in here. You have to write from where you start, 59.5, and over here 0.5 here. Okay,